Hello learner, today we will learn about the matrix multiplication. I am Ajay Kumar, Assistant Professor, Department of Computer Science and Informatics, Central University of Himachal Pradesh. So how to multiply two matrices or more than two matrices? What will be the general strategy to multiply the two matrices? So first simple matrix multiplication, how simply multiply two matrices or three matrices, okay, and what are the Strassen methods, how we can use the Strassen method for matrix multiplication, okay. So matrix multiplication can only be performed if it satisfies this condition. What are these conditions? Suppose two matrices are A and B, their dimensions are A having dimension m into n and B having dimension p into q. The resultant matrix can be found if matrix multiplication can be found if the first matrix number of columns equal to the number of rows of second matrix. If that is n equal to p, then we can perform the matrix multiplication. And what will be the dimension of resultant matrix? That is m into q. And you already know that how to if the matrix multiplication happens if A into B and B into A both are the different things. So note that in general AB is not equal to BA. So matrix multiplication is not commutative. This is very important property and generally it is asked in many examinations. So the general definition of matrix multiplication is as follow. If A is a n cross m matrix and B is m cross p matrix, then their products C will be n cross p, because in both A and B having number of columns equal to number of rows. So in general, the general element Cij of resultant matrix C, capital C, is given by Cij, that is the each element equal to summation of k equal to 1 to m, okay, and that Aik into Bkj, that you can see the k means the common number of columns of first matrix and the number of rows of second matrix. So similarly we can get the all element of the resultant matrix C, that is the each element indicates the Cij, okay. So this is the general matrix multiplications strategy. So here you can see the conditions for matrix multiplication for a square matrix. Here you can see a square matrix A and square matrix B both have dimension 2 cross 2. So what will be the resultant value? Resultant value, how to multiply the first row, that is 1 into 1 and 1, and the first column, that is 1 and 2. So 1 into 1 plus 1 into 2, that is 3. Again the second row of the matrix A and the first column of the second matrix, that is 2 into 1 and 2 into 2. 2 into 1 means 2 and 2 into 2 means that is 4. 4 plus 2, that is 6. So the element will be 6 in the resultant matrix of the second element of the first column, okay. In the same way 1 into 1 is multiplied into 1 into 2, that is 3, that is the second column of the first element. So similarly you can multiply. Again this is for the square matrix, this is for the rectangular matrix. So the first row, how to check the matrix multiplication is happen or not? So the first, number of columns of the first matrix equal to number of rows of the second matrix. Here you can see 2 and also here 2. So 2 and 2 is matched. Then what will be the resultant matrix dimension? That is 3 into 3, 3 cross 3. So you can see how the multiplication happened. So general step for matrix multiplication, what are the algorithm behind the matrix multiplication? Assume the dimension of A is m cross n and the dimension of B is p cross q, and we already discussed the matrix multiplication happens only when n equal to p. If n is not equal to p, then matrix multiplication doesn't exist, okay. So if n equal to p happens, then we have to use the for loop, that is for I in range 0 to m minus 1. So 0 to m minus 1 means the first rows, the number of rows in first matrix, and the next j loop, next for loop, will be 0 to q minus 1. What is q? Q is the number of columns of the second matrix. Agree? First number of the outer loop, first outer loop will execute from number of 0 to number of rows, how many number of rows, that is 0 to m minus 1, and the next outer loop, that is j, will go from 0 to number of columns in the second matrix, that is 0 to q minus 1. For k, what will be the range of k? That is the most, that is the innermost, that is k. K value will go from 0 to p. You can see it will go from 0 to n also, because n and p both are equal. Okay, so that's why I have written range 0 to p. And what you have to do? You have to do only one thing, that is Cij equal to Cij plus Aik plus Aik into k into j, Akj. You can see here. If we consider like Cij, that is if our I value equal to 0 and j value equal to 0 and k was initial value, I equal to 0, j equal to 0 and k equal to 0. So C 0 0, if we consider this element, this C resultant matrix, that is C 0 0, that is the first row and first column, how can we can get the value of C 0 0? So you have to what you have to do? Cij plus Aik. What is the value of Aik? Aik equal to 1 into 1 plus 1 into 2, that is 1 into 1, that is 1, 1 into 2 equal to 3. So that C 0 0 value will be 3. Similarly, what will be the value of C, because C I remains constant. If I say I equal to 0, j equal to like 1. If I say j equal to 1, so C 0 1, C 0 1 value, that is resultant matrix C 0 1, 0th row and the first column. How can we get C 0 1? C 0 1, that is I equal to 0 and j equal to 1. So Aik, I value equal to 0, I and k will go from 0 to p. P means number of, you can say the number of rows, and or you can say the number of column of the second matrix. So you have to start from 0 and go till 0 into that k equal to 0. So here 1 into 1 plus 1 into 2, that is 3 also. So similarly, you can multiply all the elements of this element of the resultant matrix element C00, C01, C02, sorry C00, C01, C10 and C11. Okay. So what will be the time complexity of this matrix multiplication? How many multiplication can happen? So you can see for innermost loop, that is kth loop, how many iteration possible, how many multiplication will be there. So if we see closely, the number of multiplication will happen m into q. M into q means m is your outermost and q is your like innermost, inner one, and the p is the innermost. So m into q into p, you can say, the because this is the nested loop, 3 nested loop. Outer loop goes from 0 to m minus 1 and the innermost goes from 0 to q minus 1 and the innermost go from 0 to p. So you can say m into q into n for a given matrix, matrix 1 having dimension m into n and matrix 2 having dimension p into q. So overall, if I say m equal to n equal to q, that means how many multiplication will be possible? That is order of nq. Okay. And what will be the auxiliary space? Why the need of auxiliary space? Because we have already two matrices, A matrix and B matrix, and with the help of A and B, we have to give the resultant matrix, that is C matrix, and its dimension is like what will be dimension? Dimension will depend upon the like 3 into 2 and 2 into 3. If we multiply, we can get the 3 cross. That 3 cross 3 is the extra space, extra auxiliary space. That's why this space have the space complexity, we can say order of m square. Okay, m into q, if I say the resultant matrix have dimension m into q, if I say m equal to q, then order of m square. So this is the extra space required, that is the auxiliary space, and the time complexity is order of nq. So this time complexity and space complexity is happen only in naive case or normal matrix multiplication cases. Okay. So what is the implementation? That implementation you can see here, the matrix multiplication, two matrices n cross n, matrix A and B, and what will be the output? One matrix n cross n, that is C equal to A into B. That matrix multiplication, what will be the parameter? Parameter is A, B. A and B are both the input, and C will be the output, and n will be the dimension. So outermost loop go from 0 to n minus 1, then another loop, that is nested loop j, go to 0 to n minus 1, and the innermost, that is k, it's also go to 0 to n minus 1, and finally you can see the three nested loops are there. So the complexity will be order of nq. So if we analyze that complexity, first step, here you can see the first step is for loop that will be executed n number of times, that is it will take order of n time. Okay, that loop for I equal to 0 to n minus 1, outermost loop. The second nested for loop will also run from n number of times, because it will take order of n time. Here you can see the for j equal to 0 to n minus 1. Okay. So this second nested loop will also go from 0 to n minus 1, that is order of n time. Assignment statement, this assignment of a statement Cij equal to 0, that will take the constant time. Another statement, the third for loop, that is innermost nested loop, will run for n number of times, and it will also take order of n time. And then assignment statement is this assignment statement, it will take order of one time, that is constant time. Okay. So as it includes the multiplication, division, addition, so it also takes constant time. Hence the total time complexity of the algorithm will be order of n cube for matrix multiplication of order n cross n. Okay, this is the simple matrix multiplication. Okay. So here one example I have stated here, matrix A have 1, 2, 3, 4, 5, 6, 1, 2, 3, 2, 3, 4, 4, 5, 6, and matrix B 1, 1, 1, 2, 3, 2, 2, 3. If we multiply, that is C equal to A cross B, how the multiplication can happen? That is C11 will be simply the first row of the first matrix and the first column of the second matrix. If we multiply the each element correspondingly, that is A00 will be multiplied with the B00, A01 will be multiplied will be the B10. Okay, and A02 will be multiplied with the B20, that is 1 into 1, 2 into 2, 3 into 3, that value will be 14. Again 1, 2, 3, that is A00, A01, A02 will be multiplied with the B10, B11 and B12, and you can get the value of 13. Similarly, all the elements will, and you can see how many number of multiplication will be counted. So that multiplication will be in the order of nq. But in this case, if I say in this case, how many multiplications are there? So here 3 multiplications, here in this case 3 multiplication, 3, 3, 3, that is 9, and 9 3 ja 27. So if the dimension is 3 cross 3, so how if I compare order of nq, that is how many multiplications are there? 3 to the power 3, that is 27 multiplications are there. 27 multiplications operations are there, you can check it. In first row, how many multiplications? 9. In second row, 9 multiplication in resultant matrix. In third row, that is 9 multiplications. So total number of multiplications are 27. And if we compare the time complexity, that is order of nq, so 3 to the power 3, that is 27. So clearly satisfy this 3 cross 3 matrix multiplication with the order of nq. what is the best way to solve that matrix multiplication in if I have order of n cube time complexity and I want to reduce that time complexity, what will be the next approach? That approach will be discussed later on. Next matrix multiplication approach is divide and conquer approach. How to divide that big problem into a small problem and how to solve that problem. So, divide and conquer method is multiply two square matrices, divide matrices A and B into 4 submatrices of each having size n by 2. We already discussed the divide and conquer approach. In divide and conquer approach, if a problem size is n, at each iteration we reduce the size of the problem by half, that is n to n by 2, n by 2 to n by 4, n by 4 to n by 8. So, as shown in this below diagram, that A and B, A, B have a dimension n cross n, and a small a, b, c, d have a, that is also a matrix, have dimension n by 2, n by 2, okay, and E, F, G, H have also the dimension n by 2, n by 2, okay. So, how to use that divide and conquer approach in matrix multiplication? Just we simply multiply in earlier cases A into E, B into G, again A into F, B into H, similarly C into E, D into G, and C into F and D into H. This is this C matrix. This have also the dimension n by 2, n by 2, okay, because we want to multiply the n cross n dimension matrix into, first step is it will reduce to n by 2, n by 2. Next step will reduce to n by 4, n by 4. So, if you count the number of multiplication and the number of division operation, then we can get the complexity. So, in the above method we do 8 multiplication. In this case you can see A into E 1 multiplication, B into G 1 multiplication, C into E 1 multiplication, D into G 1 multiplication. So, in first column you can see how many multiplication operation, that is 4. In second column also, in resultant matters I am talking about. So, 4 multiplication and 4 that is 8 multiplication, and how many divisions, how many additions are there? 4 additions. So, 8 multiplication and 4 additions in having problem size n to n by 2. So, in the above method we do 8 multiplication for matrix of size n by 2 cross n by 2 and 4 addition, okay. So, the addition of 2 matrices, it also take order of n square time. So, the time complexity can be written as Tn. Tn means total time complexity having n elements. So, 8 into T n by 2 plus 8 means 8 number of multiplication. Tn is initially the matrix have size n cross n, and Tn by 2 in the matrix of size n by 2, okay, and order of n square, that is addition operation. 8 into Tn by 8 are the multiplication operation, and order of n square, that is 4 additions, that is order of n square, that is addition operation. So, using master theorem, what will be the time complexity? N to the power log A base B, that is log 8 base 2, that is n to the power 3, and here Fn equal to order of n square. So, time complexity is overall order of n cube. So, in the above divide and conquer method, the main component of high time complexity is 8 recursive calls, okay. 8 recursive calls, it will due to 8 recursive call, because in at next step that Tn by 2 will become Tn by 4, and this value will be put into the main equation Tn equal to 8 Tn by 2. If we put Tn by 2 value here, so 8 into Tn, 8 into 8, okay, 8 into 8 Tn by 2 plus order of n square. So, this value 8 multiplication play a big role to the time complexity order of n cube. So, how to reduce that time complexity? This is the challenge for matrix multiplication. So, for reducing that time complexity, we use Strassen method, okay. How that Strassen matrix multiplication play important role to reduce the time complexity order of n q to order of n to the power 2.8 something like, okay. So, Strassen methods aim to reduce the number of recursive call, because in earlier case number of recursive call, that is 8 recursive call for matrix multiplication, for multiplication operations. Okay. For Strassen method, here you can see the matrix A and the matrix B having element A, B, C, D, E, F, G, H, all have dimension, all are the matrices, matrix within the matrix, because A, B have the dimension n, and a small a, b, c, d, e, f, g, h have dimension n by 2, n by 2. Okay. So, in earlier example here, there are 8 multiplications are there, but in this case, Strassen cases, you can see the number of multiplication is reduced by 7. How? So, P1, first it calculate the P1 equal to A into F minus H. Again P2, A plus B into H. P3, C plus D into E. P4, that value, how P1, P2, P3, P7 have been calculated. This is the method of Strassen. This is given by the Strassen to calculate the P1 to P7 value. Okay. So, we have to remember that approach of calculating P1 to P7. So, P1 equal to A into F minus H, P2 equal to A plus B into H, P3 equal to C plus D into E, P4 equal to D into G minus E, P5 equal to A plus D into E plus H. You all have to remember P1 to P7, how to calculate P1 to P7. But main point is you have to see one multiplication at P1, one multiplication operation have done in P2. Similarly, in P1 to P7 total 7 multiplication operations are there. And how many addition operations? Additions operations are 1, 2, 3, 4, 5, 6. 6 addition operation. And how many subtraction operation? 1, 2, 3, 4. 6 addition and subtraction will take same like 10, you can say 10 addition subtraction and 7 multiplication operation. So, number of addition subtraction will increase with the previous case. Here the 4 only, how many? 8. Okay, only 8 addition operations are there. But in case of Strassen, how many addition subtraction? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 addition subtraction are there. So, addition subtraction doesn't take too much time because its time complexity is order of n square. But in case of our main target is to reduce the number of multiplication operation. So, here P1 to P7 number of multiplication operations are 7. So, the A into B can be calculated using the above 7 multiplications. P5 plus P4 minus P2 plus P6. Again, these things will be given by the Strassen. You have to just mug up it. Okay. So, P1 plus P2, P3 plus P4, P1 plus P5 minus P3, P7. All will be arrangement. All this arrangement will be given by the Strassen. If we calculate the time complexity, addition and subtraction of two matrices take order of n square time. But the time complexity in this case Tn equal to 7 into Tn by 2 plus order of n square. Okay. If we compare with the naive approach, basic approach, layman approach, 8 into Tn by 2 plus order of n square. But in a Strassen method, Tn equal to 7 into Tn by 2 plus order of n square. Using master theorem, the time complexity will be order of m to the power log 7. And what will be the value of log 7? Log 7 value will be 2.8074. So, if we compare to the Layman approach of matrix multiplication and the Strassen approach of matrix multiplication approach, so you can get the benefit. How much benefit? That is 0.2. This is a very big thing from NQ to n to the power 2.8074. That will be the great achievement by Strassen. So, what are the limitations of a Strassen method? Strassen method is generally not preferred for practical application for the following reasons. The constant used in Strassen methods are high, and for a typical application, naive method works better. Okay. So, for typical application, you have to use the naive method. Okay. For sparse matrices, there are better method especially designed for them. The sub matrices in recursion take extra space. Okay. Because all time recursive calls will be there, and for recursive calls you have to maintain the stack record. Okay. So, because of the limited precision of computer arithmetics of non-integer values, large error accumulate in the Strassen algorithm than in naive method. Okay, so that's why Strassen method is not very much useful, because to remember all these things P1 to P7, and this is not easy to remember. Okay, so in general we have to use the naive method of matrix multiplication. So, what are the applications of matrix multiplication? Matrix multiplication is probably the most important matrix operation. It is used widely in such areas as network theory, solution of linear system of equations, transformation of coordinate systems, and population modeling, to name but a very few. When two matrices A and B are multiplied together in this sense, their product is a third matrix C. The operation is written by C equal to A into B, and in general Cij, a small Cij of C is formed by taking the scalar product. So, when we talk about the scalar product, we have to use that matrix multiplication approach of the ith row of A and the jth column of B. So, these all are the matrix multiplication approach. So, overall if I conclude this matrix application, first you have to use the general approach, that is the naive approach of matrix multiplication, order of NQ. Then second approach I have discussed, the divide and conquer approach. This is also very beautiful approach, because here we have to use the recursion method, recursive call. But one disadvantage is you have to manage the extra space also, because each time you have there are recursive calls. Okay, and at last we have discussed the Strassen matrix multiplication, that is also very useful, but it generally it is not widely used, because its calculation of matrix multiplication is very typical, and mug up all the things P1 to P7 is not an easy task. So you have to remember, but this is very big achievement for in case of time complexity, to order of NQ to order of n to the power 2.80 something. It's a very big achievement to Strassen. So, thank you so much.